In the world of aviation, you have icons. And then you have the Airbus A380. It's the largest passenger airliner ever built, a true double-decker behemoth that stands as this monumental feat of engineering, of pure ambition, and incredible international collaboration.
All right, so let's get into it. We're going to look at the dream that started it all, the unbelievable materials that made it possible, the raw power needed to get this thing off the ground, and the mind-bending global puzzle of its assembly. We'll also touch on the tough realities it faced in the market, and finally, the powerful legacy it leaves behind.
So our story really kicks off at the turn of the 21st century, and it starts with this incredibly audacious vision: to build an aircraft that would completely rewrite the rules for long-haul travel and challenge Boeing's decades-long monopoly on the jumbo jet.
I mean, this was the fundamental question, right? The one that Airbus engineers were staring down. This was never about just making an existing plane bigger. It was about totally rethinking what was even possible, right at the absolute edge of aerospace design.
It all started with a number that's just, well, it's hard to wrap your head around. A maximum takeoff weight of 560 tons. Just to give you some perspective, that is about 50% heavier than the legendary Boeing 747. And the scale is just staggering. We're talking a wingspan nearly as wide as a football field, a tail that stands as tall as an 8-story building, and it had the capacity to carry, in some layouts, over 850 people. That's like putting the entire population of a small village on one plane and flying them across an ocean. The A380 wasn't just an update, it was a quantum leap.
And this whole journey, from the official launch back in 2000, through that absolutely incredible first flight in 2005, all the way to its final delivery in 2021, well, it spanned 2 decades of intense design, huge political will, and some truly groundbreaking engineering.
So this is the really crucial point. How on earth do you make a 560-ton giant efficient enough to actually fly? Well, the answer wasn't just about big, powerful engines. It was about fighting a revolutionary battle against weight, a battle fought with some seriously advanced materials.
Now, a huge part of that solution was carbon fiber reinforced plastic, or CFRP. For the very first time on a plane this size, the entire central wing box, that's the massive structure connecting the wings to the fuselage, was made from this composite. Just that one decision alone saved an estimated 1.5 tons of weight.
And this is where the innovation just gets brilliant. For the upper part of the fuselage, engineers used this unique hybrid material called glare. It's basically a sandwich of aluminum and fiberglass. It kind of looks like metal, but it behaves like a composite, which means it sheds critical weight while being incredibly resistant to fatigue cracks, those tiny fractures that can pop up after thousands of flights.
When you step back and look at the whole picture, it's obvious this was a whole new era of building planes. A full quarter of the A380's structural weight is made from composites. All in all, these advanced materials saved around 15 tons. That's like taking the weight of 150 extra passengers off the plane before it even takes off.
But look, advanced materials were only half the story. To lift this lightweight behemoth, you still needed some of the most powerful and, believe it or not, quietest engines ever built for a commercial jet.
Just think about this for a second. At full takeoff power, each one of the A380's 4 engines sucks in over 1.25 tons of air. Every single second. The sheer volume of air being processed is just mind-boggling.
Airlines had 2 incredible choices. From the UK, you had the Rolls-Royce Trent 900, part of a legendary engine family. Or, from the US, you could get the Engine Alliance GP7200, which was this really cool collaboration that basically merged the core of GE's super powerful GE90 engine with Pratt & Whitney's fan technology.
This cutaway really gives you a sense of the insane complexity packed inside a modern jet engine. But the genius of an engine like the Trent 900 wasn't just its raw power, it was the sophisticated acoustic design, things like specially shaped fan blades and noise-dampening materials that made the A380 famous for its whisper-quiet cabin and for being a good neighbor on the ground.
Building the A380 wasn't just an engineering problem to solve. It was a logistical masterpiece. It was like a continent-spanning puzzle where these massive house-sized parts had all come together at one final assembly line in France.
The whole process was like this precisely choreographed ballet. The wings travel from the UK, fuselage sections come from Germany, and they all meet up in France. From there, they go by sea, then by river barge, timed perfectly with the tides, and finally, by this surreal overnight road convoy of massive trucks just snaking through these quiet little French villages.
And this quote from one of the logistics managers just says it all, doesn't it? To get these huge convoys through, they literally had to trim back trees, temporarily remove roundabouts, and re-engineer intersections in sleepy little towns, all just so these giant airplane barges could pass through in the dead of night.
But for all its technical brilliance, the A380's story isn't a simple fairy tale. The program ran into enormous challenges, both on the production line and out in a rapidly changing aviation market.
The most notorious issue, the one that almost crippled the whole project, was the wiring fiasco. Basically, the 530 kilometers of complex wiring designed in Germany just didn't line up with the physical parts being built in France. Their computer models didn't match reality. It caused a catastrophic 2-year delay and cost billions to fix.
And here's the kicker. While Airbus was busy fixing the wiring, the world changed. A new generation of smaller, incredibly efficient twin-engine jets came along. Airlines started to prefer flying people directly from point A to point B instead of the old hub-and-spoke model the A380 was designed for. Suddenly, its enormous size became both its greatest strength and its biggest weakness.
So after a production run that was shorter than anyone had hoped, what is the A380's real legacy? Well, the truth is, its impact on aviation goes way beyond just sales numbers. It's profound, and it's permanent.
Let's be clear, the A380 was a technological trailblazer. The lessons Airbus learned from using all those composites and developing its advanced electronics, they were applied directly to their newer jets like the A350. It forced airports all over the world to modernize, and, maybe most importantly, it completely redefined the passenger experience, becoming this beloved icon for its quiet, spacious, and unbelievably smooth ride.
And that feeling is something you hear over and over from people who have flown or worked on the A380. Pilots, cabin crew, passengers, they all have this unique affection for the plane. They talk about its graceful power and majestic presence. It just commands a level of respect that very few other airliners do.
And all of this leaves us with one final fascinating question. In a world that's all about efficiency and practicality, the A380 stands as this monument to sheer audacity. It was a huge bet on a future that never quite arrived, but in making that bet, it became this timeless symbol of what's possible. And it may very well remain the high watermark at aerospace ambition for generations to come.